Okay, so everyone's talking about AI these days, right? Like
Uh,
what these large language models, like ChatGPT can do.
yeah,
It's pretty mind-blowing, but it also makes you wonder, it's like
definitely.
how well can these AI systems actually think? Can they really reason like we do?
Exactly.
That's what we're going to dive into today
Right.
with this research paper called ZebraLogic.
Uh,
It's got this super long title, but basically it's all about the limits of how well these LLMs can reason logically,
okay.
especially when things get really complex and, spoiler alert, even the massive models, they can really struggle.
That's so interesting. And what's fascinating about this paper is they use these logic grid puzzles as a testing ground.
Oh, logic grid puzzles. I haven't done one of those since, like, high school.
Right. Like picture this. You've got 3 houses.
Okay.
Each one's a different color, has a different resident, and a unique pet.
Okay, I'm following.
And the puzzle gives you clues. And you have to figure out, like, who lives where, in what color house, with which pet.
Oh, right. I remember those. It's all about, like, connecting the dots, right?
Exactly. It's pure deductive logic, no outside knowledge allowed.
So it's like a detective game, but for AI.
Exactly.
You got it. But I guess I'm wondering, like, wouldn't a real-world problem be a better test? Why puzzles?
That's a good question.
Yeah.
The the thing is, with puzzles, you can really isolate that core ability to think logically.
Ah,
Like,
well,
it's not about how much data it has, but
yeah.
can it actually follow, like, a chain of reasoning to get to the right answer?
So it's like testing the engine itself, not the fuel it runs on.
Exactly. Perfect analogy.
Love it. Okay, so they've got these puzzles. They set them loose on all these different LLMs. Did they, like, crack the case? What happened?
Well, the researchers, they created this whole data set called ZebraLogic
Okay,
with 1,000 of these puzzles, each one different in how complex it is.
gotcha.
They measured this complexity in a couple of ways.
Okay.
First, there's the search space, which is basically like how many possible solutions there are. Even a simple 3x3 puzzle can have like over 1,000 combinations.
Whoa, that's a lot of possibilities.
Right. And the second way they measured complexity was using Z3 conflicts.
Okay. Z3 conflicts.
Yeah, it's a metric, basically, from
Yeah.
this powerful logic solver.
Hmm.
It tells you how much backtracking and how difficult the puzzle was.
So the higher the conflicts, the trickier the puzzle.
Exactly, you got it.
Gotcha. So they threw these puzzles with all their complexities at these LLMs, even the big ones, like Llama. What happened? Spill the tea.
Okay, here's where it gets interesting.
Uh-oh.
As the puzzles got more complex, even the most powerful LLMs
Mm.
with like billions of parameters, they started to struggle.
Really?
That's like there's this curse of complexity.
The bigger isn't always better, huh? At least when it comes to AI reasoning.
It seems that way, which
Mhm.
is a big deal because, people thought just making models bigger would make them better at reasoning.
Yeah, that makes sense. So size isn't everything. But I'm sure they didn't just, like, give up there,
Of
right?
course not. They tried some different things to boost performance.
Like what?
Well, one thing was this best of n sampling.
Best of N. What's that?
Basically, the LLM generates like multiple answers,
Okay.
and you pick the best one.
So, like, giving it a few tries to get it right?
Kinda, yeah.
Interesting. Did it help?
Surprisingly, yeah.
Mm-hmm.
Especially when they knew the right answer beforehand.
So it's like the potential's there, but it just needs a little help to find the right answer consistently.
Exactly. And that's really interesting, right?
Totally. What else did they try?
They also tried majority voting, like
Oh.
seeing which answer popped up most
Mm-hmm.
and using reward models to score the answers.
Okay.
But these were less successful.
So it's like the challenge isn't just finding the right answer. It's about understanding, like, the reasoning process itself.
Yeah, exactly. That's the tricky part.
It makes sense. But now I'm thinking, if even the biggest LLMs are struggling with these logic puzzles, does that mean we're hitting a wall with AI reasoning?
Well, that's the thing. Most models did struggle,
Hmm.
but there was one exception. OpenAI's O1 models.
Ooh,
Oh.
an overachiever.
You could say that.
Tell me more. Did it, like, break the curve?
Well, the O1 models did way better than the others.
Interesting.
And the researchers think it's because they generate these hidden reasoning steps they call chain of thought tokens, or COOTs.
Coots. Hidden reasoning steps. So it's like the AI is thinking things through in a way we can't see.
That's a great way to put it.
That's kind of freaky, right? Like, what's going on in there?
Right. Think of it like this. Someone's scribbling a quick calculation on a napkin versus writing out a step-by-step proof for a complex theorem.
Ah, okay, I see. So O1 is like the meticulous proofwriter, while the others are just scribbling on napkins.
Exactly. And the sheer volume of these COOTs is insane. O1 models produced like 5,000 on average,
Yeah.
while the others only had a few hundred.
Wow, that's a huge difference.
Right. So it suggests that O1 might be doing this much deeper, more intricate reasoning, even if we can't fully see it yet.
That's both impressive and a little unnerving, to be honest.
I know, right? It's like it's operating on a level of complexity we're only beginning to understand.
So the question is, can we learn from O1? Can we teach other models to think this way, to make those committees and break free from that curse of complexity?
That's the million-dollar question, and it's something the researchers actually looked into with this idea of self-refinement.
Self-refinement. Okay, now you're just messing with me. AI therapy.
Not exactly therapy, but the idea is that the model can actually look back at its own reasoning.
No way.
Yeah, identify errors and try to correct them.
Whoa, that's wild. Like double checking its work.
Exactly.
So did they get other models to do this?
They tried, and there were some small improvements, but it's still early days.
So this self-reflection thing, could that be the key to better AI reasoning?
That's what we need to figure out.
Okay, before we go fully down the rabbit hole of AI introspection,
Right.
let's pause for a sec. I just want to make sure we're all on the same page here.
Good idea.
What are the main takeaways from this first part of our deep dive?
Well, I think the big one is that even our most advanced AI, they still have their limits, especially when it comes to complex reasoning.
Yeah.
And just making them bigger isn't the answer.
Right, it's more complicated than that.
Definitely.
And then there's this whole thing with O1 and those hidden cotees.
Yeah.
Like maybe deeper, more intricate reasoning is possible. It's just happening behind the scenes.
It's a mystery.
It really is. And then there's this self-refinement thing, which is like super intriguing. Could that be the key to unlocking a whole new level of reasoning ability in AI?
It's definitely something to keep an eye on.
Well, that's a question we'll have to keep exploring in the next part of our deep dive.
Exactly.
So buckle up.
So we've seen that, bigger doesn't always mean smarter when it comes to AI reasoning.
Right, exactly.
But that whole thing with O1 and those hidden cotees.
Yeah, the chain of thought tokens.
Exactly.
Like that suggests there's more to the story, right?
That's right.
It's like we've stumbled upon this hidden talent, but we're not quite sure how it works or how to replicate it, which makes me wonder, is there any way to make those hidden steps visible? Can we actually peek inside the AI's mind and see what's happening?
That's the big question right now in AI research.
Really?
Yeah, how do we make these black box models more transparent? How do we understand not just the answer they give, but how they get there?
Right, because it's one thing to get the right answer, but it's another to actually understand the logic behind it, right?
Exactly. Imagine being able to see the AI's thought process step by step.
That would be amazing.
Right. It would be like having a window into its inner workings.
Yeah, then we could understand its logic, maybe even find areas where it could improve.
Exactly.
And is that even possible? I mean, AI seems so complex, so mysterious.
It's definitely a challenge, but there's this whole field called AI explainability that's trying to do just that.
AI explainability, so cracking the code of AI thinking.
Exactly. It's about developing tools and methods to interpret and understand how these complex AI systems make decisions.
Oh, that's pretty ambitious.
It is. But if we can do it, think about the possibilities.
Okay, I'm all ears.
Imagine pinpointing the exact mechanisms that make O1 so good at reasoning.
Okay.
If we can understand those, maybe we could replicate them in other models.
So it's like giving other AIs a crash course in advanced reasoning skills.
Exactly. Instead of just brute force computation,
Yeah.
we could guide AI to think more strategically, like a human expert.
That would be a game changer.
Totally. And it's not just about performance, it's also about trust.
Right. If we can understand how an AI reasons, we can trust its decisions more.
Especially when those decisions have, real-world consequences.
Exactly. It's like the difference between trusting a random stranger versus trusting a friend who, gives good advice.
Yeah, exactly.
We want AI to be more like that trusted friend.
For sure.
So this research on ZebraLogic, it's like a step towards that.
Right. It's helping us understand the limits of AI reasoning and where we need to focus our efforts.
It's all pretty fascinating, but I feel like we're only scratching the surface here. There's still this whole self-refinement thing we haven't fully explored.
Right.
Is that something that could actually make a difference in AI reasoning?
I think it has a lot of potential. The fact that O1 models seem to do this, revisiting clues, correcting errors, it suggests there's something there.
But how do you teach a machine to, reflect? Isn't that a human quality?
It seems that way, right. But remember, these LLMs are trained on tons of text data.
Right.
And that data includes, examples of human reasoning, arguments, debates, even self-correction.
So they're learning from us, in a way.
It's possible. Like they're picking up on our patterns of thought and reasoning from all that text data.
Wow, that's mind-blowing.
It is.
Like,
And maybe by prompting them to engage in self-refinement, to reflect on their thinking,
yeah,
we can amplify that ability.
like giving them the tools to think critically about how they're thinking.
Exactly.
That's a pretty powerful concept. I gotta admit, though, this is a lot to take in.
Yeah, it's a dense topic.
My brain's feeling a little overloaded.
I get it.
Maybe we should, like, pause here for a second and recap what we've learned so far, just to make sure we're all on the same page.
Good idea.
So, in this part of our deep dive, we've been talking about AI explainability.
Right.
This whole quest to understand how these complex AI systems work.
Trying to peek behind the curtain.
Exactly. And then there's self-refinement.
Uh-huh.
The idea that AI systems might actually be able to learn to reflect on their own thinking. It's pretty mind-blowing stuff.
For sure.
And it raises even more questions about the future of AI and its role in our lives.
No doubt.
Which I guess is what we'll be exploring in the final part of our deep dive.
Can't wait.
Stay tuned. Okay, so we've talked about the limits of AI reasoning, all this stuff with hidden reasoning steps and self-reflection.
Right.
It's clear there's still so much we don't know, but it makes me wonder, like, what does all this mean for the future of AI?
Yeah, that's a big question.
If we actually figure out how to make AI that can really reason at a high level, what does that world look like?
That's a huge question, and I think it goes beyond just the technical stuff.
Oh, yeah.
It's about, like, what is intelligence? What's the role of AI in society? Even, like, the future of humanity,
Wow, okay, you're really taking us there. But I like it. Let's speculate a bit. What are some of the, like, potential benefits?
Sure.
And maybe even some risks, of having AI that can really think at that level?
Yeah, well, on the positive side, imagine AI systems that can help us solve some of the world's biggest problems,
Okay, yeah.
like climate change, predicting diseases, managing resources, things like that.
It's like having a team of super intelligent advisors working 24/7 to solve these huge challenges.
Exactly. But of course, it wouldn't be that simple.
Right, because these problems involve people, economics, politics. It's messy.
Exactly. But AI, if it could reason through those complex systems, understand how everything interacts, maybe it could offer solutions that we can't even see right now.
It could change everything.
Right. And it's not just those big problems. What about AI tutors that personalize education?
Oh, yeah.
AI assistants to help us manage our lives? Even AI tools that spark creativity and innovation.
I love that.
AI could become part of our everyday lives, helping us navigate this increasingly complex world.
It sounds amazing, but I gotta be honest, I still have this, like, nagging feeling of unease.
I understand.
Like, what happens when AI becomes smarter than us? Do we lose control? I know you said we wouldn't talk about ethics, but...
No, I get it. It's a valid concern.
Yeah.
As we push the limits of AI, we absolutely have to think about safety, control.
Yeah.
What are the consequences if we create something that surpasses human intelligence,
It's a lot of responsibility.
For sure.
So it's not just about building powerful AI, it's about building it responsibly, making sure it aligns with our values, that it doesn't pose a threat.
You got it.
And that's why research like this ZebraLogic paper is so important, right?
Absolutely. Understanding the limits of AI reasoning now.
Yeah.
That helps us address those limits, build more trustworthy systems.
It's a journey, and it sounds like we're just at the beginning.
We are, but it's a journey we need to take carefully.
It's like we're building the foundation for a future where AI can be a partner to humanity, not a competitor or a threat,
I like that.
where it helps us reach our full potential.
I love that vision, and I think it's worth fighting for. The future of AI is still being written.
Yeah.
It's up to us to make sure it's a future that benefits everyone.
You've definitely given me, and I'm sure everyone listening, a lot to think about today.
Good, that's the goal.
Before we wrap up, any final thoughts for our listeners? Like, based on everything we've talked about, where do we go from here?
That's a great question. I think looking at what we saw with O1, understanding those internal reasoning processes, maybe even mimicking human thought, that's crucial.
Okay.
Along with that, we need transparency, explainability, being able to understand how AI makes decisions.
Right, not just trusting it blindly.
Exactly. And exploring how AI can reflect on its own thinking, correct its own errors, that's huge too.
So it's a big challenge.
It is.
It's not just about the technology. It's about the ethics, the impact on society.
It's all connected.
And it sounds like we need everyone involved. Researchers, developers, policymakers, even the public.
Absolutely. We need to be having these conversations, talking about the potential benefits and risks of AI, working together to create a future where AI is a force for good.
Well said. Thank you so much for joining me on this deep dive into AI reasoning.
It was my pleasure. Really enjoyed it.
It's been an amazing conversation. And to everyone listening, keep asking those tough questions, keep learning, and stay curious about the incredible potential of AI.
Could have said it better myself.